Hello and welcome to Physics Problems 1 by 1. So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself. Today's problem belongs again to the vectors playlist. And last time we talked about how to add two vectors that are not parallel to each other. And we did it through triangles. And when we're talking about triangles, if we have triangles A, B, C, and accordingly this is the angle, and this is the side against it, so it's A lowercase, B lowercase, and C lowercase. We can say that there are sine law, and it just lists the ratio of the side against the sinus of the angle, opposite angle. And those ratios are the same. So B over this sine, A over this sine, and C over this sine, they're all the same. And then there is a cosine law. Cosine law says that the side C squared equals A squared plus B squared minus 2bc cosine 2ba. Oh, what a mistake. 2ba. So c squared equals a squared plus b squared minus 2ba. Those two sides now multiplied by cosine of this angle. So basically, formula is very useful when we have two sides and the angle between them, and this was in the case of adding two vectors, and it will be the same today when we will be subtracting vectors. And as long as we know all three sides and one angle, we can find two other sinuses and take inverse function with your calculator. It's very easy, and this way we obtain the angles. So this is basic geometry. Before I go any further, I want to say about this basic geometry what it is. C squared, A squared plus B squared minus 2ba cosine, right? Cosine C. Okay, and let's consider a couple cases. For example, angle C is 0. It's a very strange situation, but basically it means A goes this way and B goes that way, right? So this is C. Let's consider angle C equals 90 degrees. So we have 90 degrees, we have A, we have B, we have C, right? And this is C capital, and we immediately know that cosine of 90 degrees, and this is another thing that you guys have to remember, equals 0. And so we immediately obtain C squared equal A squared plus B squared. And this is Pythagoras theorem. This is hypotenuse, this is 90 degrees, and C squared equals A squared minus B squared. Now let's consider second situation when we have this angle equals 0. So it's impossible to imagine, but let's decrease this angle C. So let's keep it here and let's move those together until they disappear, and it would be like this side, this point moving here, this point moving here, in the limit we have extremely, when it's very close, picture would be like this. This would be C capital, A capital, B capital, it would be A, it would be B, and it would be C. And so when we totally collapse this, we will have kind of a line. And this would be A, and this would be B, and this would be 0. And what we will have? We have, according to this formula, we will have 0 equals. But A and B are the same, like, because we're collapsing this together. So it would be A squared plus A squared minus 2. Again, B and A is the same, A squared. And what is cosine 0? We should know that cosine 0 equals 1, multiplied by 1. And we immediately see this A2, A squared, 2A squared, they will collapse, and this becomes, they all wipe out. And this becomes 0 equals 0. So this is extreme case of this scenario. And let me draw here a situation when we increase C. Increase, increase, increase. So it becomes more and more and more and more. It becomes 100 degrees. So I put this. And I will write here. So C equals 100 degrees. So when we will be like extending it, when we're almost there, our triangle would be like this. And this is C, and it is A, and this is B. And what we will have? We will have that in extreme case it would be like this. A and B, and this would be C. But let's look on the formula. Formula will become A squared plus B squared. And cosine 180 degrees equals minus 1. So it will become 2BA, right? So this formula will become C squared equals, and we know that A plus B equals A squared plus B squared plus BA. So it would be A plus B squared. And that means that C equals A plus B. And it makes total sense. So, because in this situation, this C is exactly like A plus B. So I digressed a little bit, talking about cosine law, about this formula. And basically, I looked on two extreme cases when C equals 0, C equals 180. And I looked on the case when C is equal 90 degrees, and it all makes perfect sense. So maybe you have a little bit better understanding of this formula, because it's very useful to analyze things in extreme cases, and also in the cases when we know 90 degrees, we know something else. So, but I digress here, and now I go with the task at hand, which means we have vector A and under some angle, like in the last time, we have vector B, and this theta between this direction and this direction is known. So we have vector A, vector B, and that means we know the length. And this time, last time, they wanted A plus B. And we talked about this. So last time we did. By the way, it's absolutely irrelevant where this vector starts. I can take this vector, move it here. And it will be exactly the same vector. I can take this vector and move it here. It would be exactly the same vector. It would be A, it would be B, and this would be the sum of those two. It would be another vector, and that's what we did last time, and then we analyzed triangle using these formulas. And this time, though, they want us, the question that they have A minus B. And let me digress once again. There is an old joke, what is the difference between the physist and the mathematician? And this is revealed how they solve the same problem. They face the same problem to brew a cup of tea. And so both of them use the same method. They say take a kettle, fill it with water, put this kettle on the stove, ignite the stove, wait until the water boiled, brew the tea. It's fantastic, same absolutely method. And then they faced after that immediately the problem when the kettle already is full, water is already there. And so the physicist will continue, oh, kettle is here, I put it on the stove, I ignite the stove, I wait until water is boiled, I brew the tea. And mathematician will say, well, I have this kettle, I have this vessel, I pour the water out into the drain. And now I have the problem that I already know how to solve, and I describe to you how to solve it. So, this is how mathematicians, the way of thinking. So now if I'm facing A minus B, all I have to do, I have to say that vector minus B is this. And as I say, it's exactly the same vector, let me do it nicely, parallel. And this vector is minus B. So, to obtain the negative vector, you have to flip it. Same direction, same length, but what was the beginning becomes the end. What was the end becomes the beginning of this vector. And so now, when they say A minus B, I am faced with the problems that I know how to solve. So what I do here, I take this vector and move it. And I move it here. So this vector, beginning of this vector is in the end of this vector. And I have minus B. And this would be the sum of A plus minus B. And it will be exactly the same like A minus B. And then we will solve this triangle. So, I digressed twice today, and my solution was extremely simple. Take this vector, flip it, and then use the same triangular methods as we used before. And you can do it. Let's go with what they ask in this example, because they gave us a very simple example. They say this vector is, the length is 3. This vector is also 3, the length, and this angle is 60 degrees. And they want us A minus B, right? A minus B. So, as I said, flip it. So we have this vector, same 60 degrees. Move this point here, and I can move this too. This would be the same vector as this, nothing changes. Then move this, move it here, and put it on the 60 degrees, and connect those 2 points. So this would be A minus B. This vector C, and this vector C would be A minus B. But what is the vector? The vector is the length and the angle. When we're talking about vector in space, there are 3 components. When we're talking about the vector on the surface, there's only 2. So, the length and direction. That's all. When we're talking about the vector and we know that it's along the line, it's only one thing. It's the length. And that's what we solved in kinematics about body moving along the straight line, and we will solve a lot of other similar cases. And direction is flipping, plus and minus. That's all to that. So only the value of the arrow. But here we have the surface, two-dimensional, and in two-dimensional things there are 2 things, the length and the angle. But this triangle is extremely simple if you look at this. This is 3, and this is 3, and this is 60 degrees. So let me draw it big. 3, 3, 60. Because this and this are the same, we can tell that this angle is the same like this angle. But we have 180 for the whole, so 180 minus 60, it would be 120. So 120, that means this and this would be two identical angles, and this would be 60. So we have 60, 60, 60, 60, 60, 60. Oh, that means all those sides are the same. And that means this is 3. So this C, and they use this model, the length is equal 3. And the angle is 60. So original vector is this, B is looking at 60 degrees, but the difference between A and B would be this, and it would be directed under 60 degrees, but another way around. I hope you liked it, and if so, click like, click subscribe, click bell, ask the question, write a comment, give me your own problem. I'll try to help you by solving it and putting it in the playlist from our users so other people will see it too. And that's it. Thank you very much. And next video would be about how we deal with vectors, but not from the point of triangulars, but from the point of projections. Thank you very much.